Stainless steel is everywhere. In our kitchens, skyscrapers and bridges, medical and industrial equipment, electronics, jewelry to power plant equipment. But how is it made? Workers extract and crush chromite ore, then send it to a plant for cleaning. The molten steel is molded, reheated, rolled into strips, treated, and shipped for industrial use. The cleaned ore is smelted with fuel to create ferrochrome, which is added to steel and melted at 1600 degrees Celsius. But it isn't always that smooth. In the heart of steel production lies the continuous casting machine, a marvel of engineering that transforms molten steel into solid slabs. First, molten steel is collected in a container called a tundish, and then poured into a mold using a submerged entry nozzle, or SEN. This nozzle goes directly into the steel to protect it from air exposure and impurities. But sometimes, that nozzle gets clogged. Impurities in the molten steel can build up inside the SEN, reducing or even stopping the steel flow. The question is, when and how does this clogging actually occur? Here's a clear example of a cast affected by SEN clogging. The blue line shows the stopper movement. Notice how much it's fluctuating. Meanwhile, the orange line, which tracks how much steel is actually flowing through, stays mostly flat. This tall spike suggests the stopper was moved manually, likely to break up the clogging and restore flow. Correlation analyses suggest that air humidity may contribute to SEN clogging. However, the current data is too limited to confirm this, as clogging is a long-term process. Still, maintaining consistent indoor humidity, independent of outdoor conditions, could help reduce this risk. Another key factor in SEN clogging appears to be the weight and temperature of steel in the tundish. For example, the cast 102 shows stable conditions, a near-ideal scenario. However, the cast 232 shows significant fluctuations in both weight and temperature. These variations are much more pronounced in the problematic cast, where clogging occurred. This cast also highlights a key point. Large temperature changes alone don't always lead to visible clogging. In conclusion, clogging likely influenced by long-term trends. This supports the idea that factors like temperature and humidity may only reveal their impact over longer periods, requiring broader datasets to fully understand.